Alright, so now that you know how the binary numbering system works, we're going to look at other numbering systems in this video and see how they convert from each other to each other. So this is advanced numbering conversions. In this video, I'm going to show you how to convert from the octal numbering system to the hexadecimal numbering system, and I'll show you how to convert basically from any base numbering system to any base number system, well, as far as the alphabet can go anyway. Basically, you can take something like a license plate and somehow manage to convert it to a numeric number. Kind of like this one. Alright, so previously we managed to convert from binary to decimal, decimal to binary, binary to hexadecimal, or binary to octal. If you do not have a very good idea of how to do these, I suggest looking at the previous two videos first before coming to this one. So you're probably wondering how you can convert from the octal numbering system to the hexadecimal numbering system. You can't safely just group a bunch of octal numbers together to form a hexadecimal numbering system, and it's not like we actually count from 0 to F, like we do in the hexadecimal numbering system. Well, we can convert two numbering systems together that we are unfamiliar with by simply using a third numbering system as a middleman, in this case, the decimal numbering system. So the first step that we would use to convert the base system is we would convert the number that is in a current base to the decimal form. In this case, we want to convert an octal number to decimal form or a hexadecimal number to decimal form. Then for the second step, we will convert the decimal number to the base of our choice, whether that be, in this case, octal or hexadecimal, depending on which way you are converting. Let's take a look at this octal number, 373. So for the first step, like I mentioned, we are going to turn the octal number into a decimal number. So the first thing we have to do is, well, place value. So let's go ahead and do that. I'm going to go ahead and place the 3, the 7, and the 3 according to their proper areas. There is a 3 in the 8 to the second power and a 3 in the 8 to the 0 power area. And we have a 7 in the 8 to the 1 power area. So we go ahead and we see 8 squared is 64, 8 to the first is 8, 8 to the 0 is 1, and then we are going to multiply. 3 times 64, which is 8 squared, is 192. 7 times 8 is 56, and 3 times 1 is 3. Then we will add it up, and we will have our decimal number. It is similar to how we converted from binary to decimal, but with the exception that we actually have to do a little bit more arithmetic. We can't just add up numbers whenever a 1 shows up on a particular place value. So here we have 251 for our number, and now with 251, we now have to convert this to hexadecimal, and we're going to do this by creating a series of long divisions in order to come up with our number. To convert from a decimal number to any numbering system, you will have to use long division repeatedly. First, you have to divide the number into the base number, in this case it's 16. Then we find the result and the remainder. What we do then is we take the result and we divide it by 16 again. We will continue this process until the result is 0. What we will have left is a bunch of remainders. Well, from the last remainder that you find, you want to write the number from left to right. So I'm going to show you with this very short example here with the number 251. 251 goes into 16 15 times, and we have a remainder of 11. We will then take 15, which is our result from the first number, and we're going to go ahead and divide that by 16. What we get is 0 and, of course, a remainder of 15. Now, since we already have our result of 0, we don't have to go any further. From here, we can now write our number. We will start from the last remainder, and we're going to write from left to right. So the last remainder we have is 15. And the hexadecimal representation of 15 is F. Then we're going to take the last remainder after that, which is 11, and we will give that its hexadecimal representation, which is B. And there you have it. 373 in octal is FB in hexadecimal. While they are the most popular numbering systems, you're probably wondering how we managed to convert to, well, other not so popular numbering systems such as base 3, base 9, base 13, base 36, and so on? Well, the answer is quite simple. We follow the exact same two-step rule that we did when converting from octal to hexadecimal. So let's take a look at a problem here. Let's say that you are given this number, 1A61, and we're going to call this a base 11 number, and what we want is a base 6 number. Well, we're going to follow the exact same two-step way that we did with the octal to hexadecimal number. So let's go ahead and do that now. First, we are going to convert the base 11 number to a decimal number, and then we are going to convert the decimal number to a base 6 number. So the first thing we are going to do is do our first step. So let's go ahead and do our place values here. We have 4 digits in this number, so we will have 4 places like this. 11 cubed is 1,331, 11 squared is 121, 11 to the first is 11, and 11 to the 0 is 1. Then we are going to take our numbers like so. 1 times 1331 is 1331. A times 121, well, A is just the representation for 10 in this number, is 1210. 6 times 11 is 66, and 1 times 1 is 1. Then we are going to add them all up together. 1331 plus 1210 plus 66 plus 1 equals 2608. And now we have our decimal number. So let's take 2608, and now we're going to convert it to a base 6 number using our series of long divisions. So the first thing we're going to do is take 2608 and divide it by 6. You can use a calculator for this one. 2608 divided by 6 is 434, and we have a remainder of 4. Now we're going to take our result, 434, and we're going to divide that by 6, and we will get 72 with a remainder of 2. And then you're probably not going to need a calculator for the rest of this one. 72 divided by 6 is 12 with a remainder of 0. 12 divided by 6 is 2 with a remainder of 0. And 2 divided by 6 is 0 with a remainder of 2. Now we're going to take our 5 remainders here, and we're going to form our base 6 number. So first we're going to take the 2, the last remainder that we have, and we're going to write that. Next, we're going to take our next remainder, which is 0. We're going to follow that by the other 0. Then we're going to take 2, and then finally the 4. And we are left with 20024. And there you now know how to convert from one unfamiliar numbering system to another unfamiliar numbering system. You can now take any number of numbers or letters, a combination of it anyway, and change it to a decimal number and then convert it to any base number that you wish. Though the only time you're probably going to need it is in homework problems and in octal to hexadecimal conversions. So anyway, that is the video. I thank you all for watching. Next, we're going to look at binary arithmetic. So please thumbs up this video. Thumbs up, comment, and subscribe, and I hope to see you next time. Thank you for watching.